Karz Talks, where opinions are facts and facts are opinions. Electric vehicles, EVs. That is the topic of today's video, but not normally what I would ramble on an EV about. This time, I'm actually looking out for the EV and its future, wondering why these smart engineers are doing the things they do. It doesn't take a rocket scientist to understand the biggest problem with EVs right now is just plain and simply their affordability. No one wants to really spend the kind of money that EVs are going for unless you get it used. Usually you can pick up used Teslas for practically nothing. But if you wanted a new EV, or if you didn't want Tesla and you went with any of the other legacy automakers making EVs today, none of them are relatively affordable. You know, for EVs, they're becoming more affordable, but you're not getting an EV. You're not getting an entry-level EV at the same price point that you are traditional internal combustion engine powered vehicles. I mean, you can still get brand new internal combustion vehicles for like 20 grand. You couldn't even touch a new EV for twice that much. You want more people to buy EVs, you want more people to drive EVs, then you gotta make them more affordable. And unfortunately, the biggest driving expense of an EV, what makes them super expensive, is the battery. The battery is the single most expensive item in the EV. The cost to produce a battery is ridiculous. You get that cost down, you get the overall cost of the vehicle down. Also, when the time comes to replace said battery, because it happens, instead of totaling out the car because the replacement for the battery is more than the car's value, if for, I don't know, any reason you could use a smaller battery that costs far less to replace, where really it no different than replacing an engine, then maybe it would make a lot more sense for people to keep on to EVs longer instead of just basically throwing them out. I mean, they're just an appliance, right? You use it, it breaks, you throw it out, you get a new one. But that's not sustainable. How is that environmentally friendly? It's not. And people who don't want to cycle through new cars every 2 years, you want to be able to at least fix things when they break. At least for EVs, they are pretty reliable because there's not much going on. The only big thing you got to worry about is that damn battery. So I've always thought to myself, why do engineers not use transmissions in an EV? And I've thought about it and I've thought about it and I thought about it. I'm like, there's got to be some reason. These men and women, they're definitely smarter than me. They don't wear their hat backwards, so they must know something I don't, right? This is where I've come to terms with the whole situation. Most of the people agree that an EV doesn't need a transmission. And you know what? I don't know if I'm willing to jump on that train because I think there is definitely a better way.
Do electric cars have transmission like conventional cars? The answer is no. The majority of electric cars use gear reducers instead of multi-speed transmission. Here are the reasons. First, the electric motor can put out the highest constant torque at low RPM when internal combustion engines need to reach a certain range of RPM. Second, the maximum RPM of electric motor can reach up to 16,000 RPM, but regular combustion engine reaches 6,000 is red line. What benefit will bring to you in this change? It brings you faster acceleration and lower maintenance cost for transmission.
Lower maintenance costs, faster, lower maintenance costs. While he may be right there, what he's not considering is efficiency and if you can get the same amount of performance out of a less powerful motor, therefore the battery pack can be smaller and reduce the overall cost of the car. That's my argument right here. So his take on it is the reason why EVs don't use transmissions is to reduce complexity and create another failure point. Okay, I agree there. And they would be faster without it. No, I don't necessarily agree there, and I'll explain why later in the video. And it's no secret that EVs are fast. They're fast to accelerate to a certain point, and then they kind of peter off. We'll get to that later in the video. But, you know, like that's what everyone says. And see how he said that they use gear reduction? Gear reduction is pretty much how most transmissions work. The difference between an EV's implementation of gear reduction and something you would find in a Honda Accord is the amount of ratios available. Manufacturers are discovering that maybe it's beneficial to have at least 2 gears.
Gear reducers are devices used to transmit mechanical power from an electric motor or other driver to a driven load. In the world of pumps, they convert the high-speed, low-torque input from the motor to a low-speed, high-torque output at the pump.
If gear A has 8 teeth and gear B has 10 teeth, the ratio is 10 divided by 8, which is 1.25. If gear A rotates at 150 RPM, then 150 divided by 1.25 equals 120 RPM. If gear A has a torque of 20 Newton meters, then 1.25 multiplied by 20 gives us 25 Newton meters.
But automotive transmissions also are technically gear reducers. They're also gear multipliers. They're both. And my understanding, the difference between a gear multiplier and a gear reducer is a reducer turns high speed, low torque into low speed, high torque, and a multiplier does the opposite, turns low speed, high torque into high speed, low torque. And that's the difference. When you have a transmission with, let's say, 6 different gear ratios on a car, the first, usually first 4 in a typical 6-speed transmission, usually the first 4 are multipliers. It means they multiply the torque coming from the engine. That's why when you dyno a car, you want to be close to a 1-to-1 ratio as possible to get the true engine output and not have those gear ratios messing with the torque. By taking high torque, low speed, and converting it into high speed, low torque. And the benefit is having more power to move the vehicle from a stop. And then your gear reduction gears allow the vehicle to be more efficient at higher speeds, higher wheel speeds. But the EV has something different going on because an electric motor's efficiency, it doesn't work the same way a internal combustion engine does. You know, internal combustion engines' efficiency is rated off how much fuel they consume. Well, generally, they're going to consume far less fuel at a lower RPM. An electric motor is a little different in how it works, where it actually is more efficient at max RPM. But that's just because they are not efficient in generating power at max RPM. They're only efficient at operating and not pulling as much current at high RPM. And that comes right here. You can see this little graph. Efficiency, where it's most efficient, is towards the top end. It looks like in this particular graph, it would peak at like 90%. 90% shaft speed at the electric motor is where it's going to draw the least amount of current, which means you get a lot better efficiency out of the battery, right? But if you look, it makes its most power like at 50% RPM. So it has a power curve, right? So this is something you see a lot when EVs with the traditional single speed, basically it's because they can spin so fast, an electric motor can spin so fast, they say, oh, well, you don't need a transmission. But that's why you see right here, you got the initial punch in power. But if you ever watch EVs race, equivalently high horsepower, multi-speed internal combustion engine cars, usually by a certain speed, that combustion engine car is starting to just take off. Why? Because of that damn transmission. It allows the engine to stay where it needs to be to make power, even though wheel speed is increasing. However, on normal EVs, once wheel speed goes up to wherever it's going to go and you max out your efficiency, you're out of your power efficiency window, you're on the downslope of that curve, well, that's where your problem. So theoretically, if you want max power, you want to keep that output shaft speed at 50% all the time. So under power, when you're accelerating, you can maintain 50% output shaft speed, but then when you're cruising on the highway or just whatever, you can reduce the gears and get that shaft speed really high. I guess you could gear it in a way where it's almost like a 1-to-1 for efficiency, but when you want power, you have to do the opposite. And that's something I don't think really people think about too much. There is obviously a benefit to using a multi-speed gearbox. It would have to be very specifically tailored, the ratios themselves, to the electric motor, because an electric motor is going to use or benefit from different ratios than an internal combustion engine would. But the benefit here is you get to use a smaller electric motor and you can still maintain high torque for taking off, just like a gearbox allows, transmission allows in a car. But then when you need the efficiency, you can also get that. But you have to remember, as I mentioned, the efficiency in an EV or an electric motor doesn't come from low RPM. It comes from high RPM. So you have to tailor the gear ratios to be suitable for this. Really, it's almost like a CVT would be the ideal type transmission. I don't know if I would want to use a CVT with something like an electric motor, but theoretically that would be the best. And the thing is, what happens if you can get, I don't know, in most driving instances where you can keep the electric motor in top efficiency because it's always spinning at a high RPM, but low torque? I mean, theoretically, if you can use a less powerful electric motor and still generate the same amount of torque as a more powerful motor through gear multiplication and reduction, then you theoretically could get the same efficiency and use a smaller battery, reducing the cost of the vehicle. Also, you gotta remember, like 80% of an EV's weight comes from that damn battery pack. You reduce the battery pack, not only do you reduce the cost, you reduce the weight. So that's also better because it's less weight. Your tires aren't gonna, wear out like crazy, And also, using smaller battery pack uses less resources to make per vehicle. I mean, there has to be a way to do this. Why no one has really done this, I don't know. They gotta be working on it. Some engineer somewhere has to be racking his brain the same way I am. Except they have much more knowledge than I do, and they have the funding and resources to actually take all of this theory and put it into practice. Because I can't, all I can do is blab about it on the internet. Yeah, so I don't know. Just me, off the cuff here, just thinking about it. I've been thinking about this a while. I decided just to kind of put a little bit of thought into this, research a couple things, and realize that the logic isn't as simple as I thought. But in theory, there's still a benefit to a transmission of some sort for an EV. If you have anything to put to this, let me know. Put your thoughts in the comments. I think it's going to wrap it up here for the video. If you liked the video, please give it a thumbs up. Share with everyone you know. If you want to see more content like this and you haven't already, go ahead, subscribe to the channel. Keep a lookout for next Karz Talks video.